All right, guys. Good evening and welcome to another episode of our one and only Friday live live session. All right. So as discussed earlier today we'll be discussing about how to handle transactions using the transactions and account balances for fintech applications. So today is basically my first solo live session, and yeah, just trying to check out how it would be like doing some live coding. Right. So nothing too serious, but then basically today what we'll be doing is creating already we have an already existing projects which I have already added to the description. The GitHub link is on the description. A Next.js project. On that project, I've gone ahead to do some modules like the auth module, the user module, the auth module, user module, the wallet module, and the wallet module basically. So for the wallet module, it's just the entity that's there and the module.ts file. So what are we going to be doing today? Okay, so this app currently is an API using SJS. It is going to be a let's say let's say more of like a base application for further content coming out from this channel. So Okubo actually means money in Ijo. So yep. All right. So just like say a prompt that if you haven't subscribed to this channel, kindly do so, and then turn on notifications so that way you'll be notified when next I go live. And most times I usually have guests on the show. Like last week we have Jezreel. Jezreel showed us how to use Notion as an ACCMS for your front end application. So without further ado, without much ado, let's dive right in. So before we dive right in, let me just give you a rundown of what exactly we have existing. All right. So while on the auth module, we have basically our DTOs folder, right? We have the auth controller, we have the auth service, and the auth module, of course. In the auth service, we are basically registering a user and logging the user. So the register service calls the user service, which takes us to the user service. The user service has three methods. We have the create user, which basically creates a user and saves the user to the database, get user by email and get user by ID. Then moving on to the wallet module. Wallet module basically has nothing but the wallet module and our wallet entity. So right, so if you're joining and I might not be able to get questions, but then yeah, because you could still drop your questions and you could still drop your questions and I'll probably be able to attend to them. All right, so where do we start from? So basically, I want to start from the wallet entity. Basically, yeah, the wallet entity has a one-to-one relationship with the user entity, as you can see. But then, yeah, in order not to take forever, setting up a project, I decided to put things in place and get up and running. So this video promises to be short, 30 minutes max, hopefully. I have my code running up on port 8000. I should probably increase this so that way you could see along. But okay, so to kick off, I'll continue with creating the wallet entity. Creating the wallet entity where I'll continue creating the wallet entity, fleshing it up. All right, so naturally you might be tempted to you have a wallet and the wallet has a user has a wallet. you might be tempted to go ahead and start saving the balance directly as a field. But then, we won't be doing that in this video. Rather, we'll be populating the balance, the user's balance on the fly, when that way, based off his transactions. So if he does a deposit, if he does a withdrawal, or he does anything, we save those transactions basically. Then whenever we want to get the user's balance, we can always now query all the transactions and debit and credit. Basically, subtract the from the subtract debit from the credit, and we'll have the user's current balance. All right. So that's basically the rundown and how things will go. Then also again, just as a rule of thumb for me, basically coming from my background, a business administration background, I did a little bit of accounting for 2 years in school. So the accounting principles will be a guide for us in this project we are working on. Basically, so the accounting principle, which particular states that for every credit transaction there has to be a corresponding debit transaction. So we'll be keeping our transactions types at credit and debit. But before we go ahead to that, let's have a transaction entity created, so that we can get a grab of what's going on. So let's go transactions dot entity dot ts, and for each transaction, we're going to be having sports class transaction, a automatically generated primary generated column, which will be using UUID. That will be of type string. Then also we'll have our create dates column, created that should be of type dates, and updates dates column with that of type dates. Okay. So up next is gonna be the transaction type. So that's column. Right, so tx underscore type. So for transaction type, basically it's gonna be a string, but then we would want to basically have a fixed type, so that way there cannot be any mistakes. So move over to create a new folder for, let's call that our interfaces. No, let's do enums first. So we'll have a new file called tx type dot ts, and we'll be exporting enum tx type. Tx type will be so first of all, have a credit, and we're gonna have debits. For enums, all right. So moving on to our tx type, to be of type tx type, which is an enum. Format this. All right. So yeah. So basically, we'll be saving credits and debits. Yeah. Then also we'll have a column for this column would hold the amount for the transaction, so type number. So just something I learned from Paystack. What Paystack does is basically they save um, the amounts in the unit form, basically Kobo. So if you notice now, previous Paystack videos, where you see that Paystack receives amounts in Kobo in the unit form. So I was basically multiplying the amount which I want to send to Paystack by 100. So for that purpose, I would suggest also that I would advise also that you keep that same format. That way you don't even lose any form of units of during conversions or rounding off or whatever you're doing. Basically, save your amounts in Kobos. So that way, if you are going to be front end is going to be rendering anything, it can easily just get you the exact figures. That's clear. All right, so yep, and then each transaction should belong to a wallet. So minute to one, and go type wallets. Wallets dot transactions. So this would always show true until we go to the opposite side of the minute to one. Type or all right. So if we go to our wallet now, entity, we can then add our one-to-many relationship, because one wallet can have multiple transactions. Okay. Action. No. Oh yeah, there's a transaction coming from totally skip that. I hope this doesn't cause any problems along the way. Right. So we have transactions. That will be type transaction array. That's for our wallet for now, for our wallet entity, and basically that's for our transaction entity. We have the create the ID, the create date, column, amount, wallet. Okay, we could also throw in an extra column. Of course, you want to always save have a unique what they call it, reference, transaction reference, basically. So that way you can identify transactions that are unique, and this will be a string. So this is going to be unique true. Unique is true. Okay. Really gonna be unique? Are you gonna be unique? Are you gonna be unique? Transaction reference. Okay, yeah, that's stay unique for now, or not. Okay, for the scope of this project, there's not gonna be. It can stay unique. There's not gonna be any conflicts or whatsoever. All right, so now with the entities out of the way, we can now move on to have our services that will be doing most of our most of the methods for transaction creation and saving and account balance and the rest. So let's do this by next generate. We have a module, so service is wallet. All right, so I'm basically doing everything under this wallet module, so that way there's not much moving parts. But then for it to be best to separate constraints and have transactions stay on their own and wallets stay on its own. That's because you have a wallet controller, and you also have a transaction controller. But then for basically for learning purposes, let's move ahead. In oncoming videos, I'll probably just change this back to how it ought to be. Okay, so we have the service up and ready. Up next is the controller. Next generates controller wallets. And okay, there it goes. So after linking our wallet to our transaction, and our wallet is basically linked to a user, we want to do the first method of getting wallet balance. So okay, have a constructor. Yep. In our constructor, we'll be having we'll be having our data source, so that we so also again, one thing I learned basically, I've been using it on Prisma, but then I haven't used it on using type ORM. Was how to handle transactions, so that way if an operation, a database operation in which you are saving multiple items fails, you could revert back the prior ones. I did that in the user service where you're right, a new user is created, password is hashed and saved, then also a wallet is created for that same user. So if anything happens along the way and it fails after user has been created, you the user that was created rolls back. It's not saved to database, absolutely saved to database until everything works out fine and it returns what it's meant to return. So that's basically transactions, and you do that using entity. It's not entity framework. You do that using type ORM's transaction, and that's basically what we'll be doing in our wallet service eventually, if at all a need for it. But then when you learn something new, you want to keep on trying to use it, and you can only do that if you're using data source. You can only do that if you're using data source. So over in our common, we do have a DB and data source setup. So where we are setting up our database connection, and this data source is then injected in our app module. Yep, that for module for roots. So also again, one thing I also learned regarding data source, you basically don't have to start injecting each repository, or each repository in your services or wherever it's being used. You could just have access once you have this once you have your data source injected. You basically could just get the repository directly from there, as you can see where we did that in our user repository and the wallet repository. All right, so like I said, this code is basically on YouTube, and the URL is in the description below. You could check it out. All right, moving back to our service, our wallet service. Our first method will be to get wallet balance. And right, so we'll need the wallet ID, which is of type string. Right. Wallet ID type string. Okay. So making use of the data source, we can now get our wallet repository. Repo equals to this data source dot get repository. and we're passing our entity called wallet. Yep. And since we're not using wallet repository later on, we just our console wallet will be equals to dot find one where ID is equals to wallet ID. All right. ID. If no wallet found, or wants to throw a new not found exception. What is common, and the error will be wallet not found. All right. Then we want to return our wallet. Okay, I want to get wallet balance basically. Okay, my bad. So for wallet balance then now, okay, we would want to have our relations of transactions coming in through from this guy. So that way, when we get that, we can have a wallet of transactions, and we can now do our calculation from that. So knowing that, we have credit transactions and we have debit transactions, we want to let's separate them. That would be it, right? Okay. All right. Credit transactions, which are incoming inflows, will be equals to wallet dot transactions. Oh, forgot to do the wait. Wallet dot transactions dot filter. We have TRX, where TRX dot TRX type equals to so we have a TX type enum dot credit, and the same should apply to our debits. Debit. Okay, so credit transactions. Okay, let's move this to credit. Okay, total credit transactions. Let's rename it total credit transactions. Total credit transactions and total debit transaction. The reason why I'm doing that is because I would want to total them what we have. So reduce takes in okay. Yep. And we want to return accumulated plus transaction dot amount. Same applies to reduce zero. Now this is basically totals all our credit transactions and our debit transactions, and our wallet balance would be equals to total credit transactions less total debit transactions, and we can now return wallet balance. That's is how we'll probably just not like that. That's how we're gonna do our get our wallet balance. Although yes, this can be refined along the way. This can be refined along the way. We could get this through the transaction side, in which you just get transactions where wallet ID matches the wallet ID, and that way to save us. Well, it's basically the same one trip to the database. Um, yeah. So that's a simple way to get our wallet balance. And so if we go to our controller and we can now inject our wallet service. And okay, so we have this will be a get requests balance. Sync get wallet balance. Okay, get wallet balance. Okay, so we're having our wallet ID coming through here. Match balance. And we're getting that from our params. Okay, so this reminds me of my colleague Godwin, who is always big on validations. So he wants to be sure that that wallet ID that's coming in is actually your ID, and it's ready. It's there. It's not undefined. So that's something I've come to take from him, building while working generally with working generally. So in order to validate that wallet ID, we'll use a DTO, which we'll call the wallet.dto.ts, and we're going to export class wallet ID DTO, and we'll want to use the class validator middleware decorator UI. This is UI ID, and it's going to be a string. It's going to be defined. It's not empty. And if you ask me, wouldn't is defined and all of them cancel themselves? But then I work with Godwin. Eventually, you get used to it. All right. So this will be wallets underscore ID, which is a type of string. And now we can now validate, make sure that our wallet ID is provided through in this controller. So for the params type wallet ID DTO. But that, and now we can return wait this dot wallet service dot get wallet balance, and passing param dot wallet ID. And yeah, basically we want to get our wallet balance from this method. Okay, so we'll go ahead to test this eventually, right? But then before we go ahead to do that, let's do some new methods in which we can save transactions and also see we can have data in our database which we can use to test. All right, so next transaction, let's call it credit wallet. Yep. Okay, next method, sorry, not transaction. And for the credit wallet, we need TTOs who can use to credit the wallets. Yep. Create a new, okay, I have a TTO, and let's see. Export class. Okay. Transaction TTO. Transaction TTO. Also we needing is just an amount. This number. Hit that. This number is defined. It's not empty. And the amount with type of number. Right. Yep. That's it. Okay, well, moving back to our credit wallet. This credit wallet now is expecting, we'll be expecting a string of wallet ID. String, and also data, which will be transaction DTO. It's a simple operation. We'll be using data source. Okay. So we want to first of all get the wallet. But we won't be needing the relations for this scenario. Of course, we want to do the check if there's no wallet found. Okay. There's no wallet found. Okay. All right. So that's basic checks. So while working with financial apps, you want to be obnoxious. You want to be you want to trust no one. Don't trust the user. Don't trust the client. Just do your checks and validate accordingly. If it means double validating, please do. And that'll be it. That's basically it. All right. So now we know that the wallet exists, and we've gotten the wallet. Most definitely, let's move ahead to create a transaction. Okay, so remember in our transaction entity, we did set the transaction reference as unique, right? So chances are that the transaction reference will be coming from your provider, like Paystack or Flutterwave or Block. But then, so the reason why I did set it to unique, so that way, you wouldn't have to credit or debit a transaction twice, debit a wallet twice, because of you want to do it twice, so that way, by using the same transaction reference. So let's say Paystack sends you a webhook, and you have already treated that webhook before, right, with that transaction reference. So having it as unique means that, okay, yeah, this transaction reference has already been used before, so it shouldn't be reused. But then in this case, we are generating the transaction reference on the fly. So basically, if we are basically integrating Paystack or something, probably we're taking the transaction reference through the transaction DTO. All right. Moving on. Okay, still. Right. Well, moving on. So we want to first of all create a transaction. Just to this data source. The repository. It's gonna be a transaction. Transaction entity. So as at this point in which if at all you are receiving a transaction reference, you want to check if the transaction reference already exists. If it exists, we throw an error. But then in our own case, we are not receiving transaction reference externally. Rather, we are creating it ourselves. Dot create. Okay, so wallet is gonna be which you can have this. The amount will be data dot amount txref let's use okay, new dates now. Okay, get time. I'm thinking .net, not get time. Why are you screaming? Transaction entity has a wallet. Why? Quickly check. Creating a new wallet. What am I doing wrong here? Getting transaction using the right entity. Let's just proceed. Okay. Yeah, this is where the problem is coming from. Okay, let's cast you. There we have it. Okay, we have the amount, transaction reference, transaction type. Transaction type will be our TX type dot credit, because we're crediting the wallet. Okay, and I think that's basically it for our transaction. We have the amount, we have the transaction reference, we have the wallet, we have transaction type. And yep, transaction has been created. Since it's a credit transaction, we just no checks to see if the wallet balance is balancing or not balancing. So with this done, we can now return. Let's throw in a message. Transaction created. Transaction created, and for data, we can give our transaction. Yep, and now we've done the credit transaction. Up next is debit transaction. So it's basically similar, but with an extra check. Like I said, be paranoid. Let's call it debit wallet. So at this point in time, we would want to ensure that the user has enough balance before debiting the wallet. So that's the only extra check we'll be doing. And so if there's wallets, okay. Now let's reuse the get wallet balance. So const wallet balance that will equals to await this dot get wallet balance, and we're passing in the wallet ID, which will be yep. Ensure that this is a number that's coming through. Yep, it's a number. So we want to check that the amount that is being sent. So if data dot amount is greater than, we'll let the balance, we want to throw an error. We want to throw a new unprocessable entity exception. Sufficient funds. Yep. Then create a transaction. Type will be debit, and transaction created, return transaction. So this is a way simpler method than when you have the wallet balance hard code, not really hard coded, but saved as a field in the database, and you now have to reach out to the database to update that balance. Rather, by using the credit and debit transactions, which are going to be negative and positive, we can now clear that out simply on the fly. And just in case to have probably just much transactions going down, you don't want a situation where the database is locked out and the update to the balance is not done. So yeah, this basically is everything, right? So then moment of truth. Let's quickly add the new methods, the endpoints for debiting and crediting the wallet. Wallet ID slash credits. As always, we want our credit wallets from param identity. Then also we want the body to be transaction detail. Okay, one thing we could also do again to our transaction detail is basically make a minimum to be 100. Like this now, this makes sure that the minimum transaction is actually 1 kobo at all time. You don't get to send the zero kobo. All right. Okay, we return with this. That's what let's save it to credit. Yep. And the same for the debits. Debit wallets. All right. Okay, so I think I've passed the 30 minutes I was planning to stay on this call, but then we're rounding up. Moment of truth has come. At this point, we test. Okay, so let's start with moving over to Postman, and yeah, I have my login. So if you notice, I didn't really do anything with respect to using the validation. Protecting the routes. We didn't do it regarding protecting the routes. So forgive me, but then time is of an essence. So let's add the request for this request will be get wallet balance. Okay. Wallets _ID /balance. Okay, another voila comes through. Okay, we need to get a wallet ID. Okay, so let's see. Um, Okay, in our get user, let's include a wallet ID to it. Get user by. So let's return spread the user response object and also have wallet underscore ID to be user dot wallet dot ID. So that way we are able to get the wallet ID for a current user that is logged. Yeah, for the current user we have, okay, because basically logged in is of no point. So let's send that. Yeah, we have our wallet ID coming back. If I was to do it a better way to do this would have been to get the user that's logged in, right? Then also extract the user's wallet ID from that user, so that way there's no room for error in providing the wrong wallet ID in the endpoint by the client. All right. Okay, so let's send this. What do we get? We get 0 because there's no transactions recorded for this wallet, so that endpoint works fine. So let's do the add requests credits wallet and balance credits, and we get the wallet ID from here. Okay, it's gonna be, oh, we haven't added the, have we? Oh yes, we have. Okay, let's make it a post. Posts. Save that, back to Postman, and let's send. Okay, so if we send now, we should be able to get. Okay, let me change this to post. We should be able to get the the amount should not be null or undefined. That's our validation we did. So moving over to the body, let's use raw type JSON. Great. So we have the amount. Amount will be. So if we make the amount a string, we should be able to get a validation issue. Oh, it's casting the number. But then, yep, it's casting the number and it's not. Yep. So yeah, we're able to do create transaction of 500 naira. Remember, we're adding using the extra lines. So yep, credits is returned, transaction reference is generated, and wallet. So if we call our get wallet balance, ooh, 0, 0. Okay, what's the issue? Okay, chances are our transaction hasn't synchronized yet. Okay, why that was not supposed to happen? Credit deal is 5k. Send, sorry, get wallet balance, send still 0. Okay, let's see from our wallet service. Nations, okay, COG wallets. Transactions here. transactions. Okay, let's see what that is. Get wallet balance endpoint. Okay, for my first transactions are empty. Transactions are not saving. Transactions are not saving. Transactions are not saving. Why is our transaction not saving? We have our transaction. Okay. Let's do a quick one. So somehow, for a weird reason, I am unable to get my database. So let's see, let's see if we have transaction saving. Wait, this dots data repository data source dots gets repository. Transactions. Let's find transactions. Get wallet balance. Okay, so I guess my bad. I did not save the transaction. Yeah, just realizing that now. Very funny. So after the transaction was created, yep, we need to wait these dots. This is repository transaction dot save. Yep, that's the issue. When you work with Prisma for a while and you realize that you don't have to run the save anymore. So let's create the wallet now and get wallet balance. Voila, we get our 500 naira balance. So then let's do the debit wallet balance. Debit the wallets. Debit wallets. So I didn't save this guy. UA posts. URL. Debit. And the wallet ID is coming from wallet ID. Our body, let's copy this guy. Bodies. Let's use raw. Okay, so let's attempt to go above what we have in our balance, and if we send that, sufficient funds, so everything works fine. Save that, and if we do a withdrawal of 50 and we get our wallet balance, yep, it's all working fine. So basically, in this short video, we've been able to handle wallet balances and handle them and handle balance, and also credit and debit using transactions. So yeah, this has improved for many improvements. So in the subsequent videos working with the Okubo API, I will be doing this improvement and pushing. So basically, you could have access to this repo yeah, to the changes and to follow along. I'll quickly just add this guy we've just done. Dash M, and the transactions, and push this guy here. So you have access to the repo. So if you are new to the channel, basically Friday Live series are a series in which I get to discuss technology, discuss finance, fintech, scopes, businesses, and products, and also a little bit of compliance when you're building your fintech products. That's it for today. Join me at the same time next week, same day, Friday 6 p.m. for our next episode of Friday Live series. I do hope this was educative enough, and I appreciate feedback. And also, if you haven't subscribed to the channel, kindly do so and turn on notifications so you get notified when I go live next time or when next I upload a video. All right, guys, thank you very much and adios.